If we have y equals to sine of m times sine inverse of x, then we need to show that this given expression or this equation holds true. So let's begin. Here we are provided with y equals to sine of m times sine inverse of x. So what we'll do is we'll take the derivative on both sides with respect to x. So that is plus derivative with respect to x of sine of m times sine inverse of x. Now we know the derivative of the sine function, that gives us the cosine function. So here we have cosine of m times sine inverse of x, but we'll need to use the chain rule to take the derivative of m times sine inverse of x. So we'll do is multiply it to derivative of m times sine inverse of x. Now here m is a constant, so we can pull it out of the derivative. So we have m times cosine of m times sine inverse of x multiplied to derivative with respect to x of sine inverse of x. Right. So let's find out the value. So this gives us m times cosine of m times sine inverse of x. Now derivative of the inverse sine function, that's 1 over square root of 1 minus x squared. So this is the value of the first derivative of y with respect to x. So let's label this as equation number 1. Now what we'll do, we'll square both sides. So let's square both sides, and this is going to give us dy over dx whole squared equals to m squared times cosine squared m times sine inverse of x, whole thing divided by 1 minus x squared. Now we'll cross multiply 1 minus x squared with the term on the left hand side. So this is going to give us 1 minus x squared multiplied to derivative with respect to x whole squared equals to m squared times cosine squared of m times sine inverse of x. What we can do, we will use an identity, which is cosine squared x plus sine squared x, that's equals to sine squared x equals to 1. So that means cosine squared x will be equals to 1 minus sine squared x. What we'll do, we'll convert this cosine squared into sine squared. So that means this will become m squared multiplied to 1 minus sine squared of m times sine inverse of x. Now this is done so that we can replace sine of m times sine inverse of x with y. So this will be equals to m squared times 1 minus y squared. So this is 1 minus x squared multiplied to derivative of y with respect to x whole squared. Fine. Now what we'll do, let's label this as equation number 2. Now we'll take the derivative on both sides with respect to x. So let's do that. We have derivative with respect to x of 1 minus x squared. This was multiplied to derivative of y with respect to x whole squared, which is equals to m squared is a constant. We'll multiply it to derivative with respect to x of 1 minus y squared. So here we'll have to apply the product rule. So we have 1 minus x squared. This is multiplied to derivative with respect to x of derivative of y with respect to x squared, plus we have derivative of y with respect to x squared multiplied to derivative with respect to x of 1 minus x squared, which will be equals to m squared times derivative of x derivative with respect to x of 1 minus derivative with respect to x of y squared. So let's find out the value. So we have 1 minus x squared multiplied to, so here we have derivative of y with respect to x whole squared. Here we'll have to apply the power rule. So that means we have 2 times derivative of y with respect to x raised to the power of 2 minus 1 multiplied to derivative with respect to x of dy over dx. So here what we have done, we have used the chain rule, plus derivative of y with respect to x whole squared multiplied to derivative with respect to x of 1 minus x squared. So that's simply 0 minus 2x, which is equals to m squared times 0 minus derivative of y squared with respect to x will be 2y times dy over dx. Right. So that means we now have 1 minus x squared multiplied to 2 times derivative of y with respect to x, multiply it to, so this will become the second derivative of y with respect to x, plus derivative of y with respect to x whole squared, multiply to negative 2x, so that's equals to negative 2y times m squared times derivative of y with respect to x. Right. Now let's bring this term to the left hand side, so this will become positive. So we have 2 times 1 minus x squared times derivative of y with respect to x times second derivative of y with respect to x, minus 2x times derivative of y with respect to x whole squared, plus 2 times y times m squared times derivative of y with respect to x equals to 0. Now from these three terms, we're going to take 2 times the first derivative of y with respect to x as the common factor. We get 2 times derivative of y with respect to x. So this will be now multiplied to 1 minus x squared times second derivative of y with respect to x, minus x times first derivative of y with respect to x, plus m squared times y. So this is equals to 0. Now 2 times derivative of y with respect to x, so this will not be equals to 0. So that means we have 1 minus x squared multiplied to second derivative of y with respect to x, minus x times derivative of y with respect to x, plus m squared times y equals to 0. And this was what we are asked to prove.